Okay, the recording is on. Um, let's see the agenda. Nicholas, is it you who's going to go first?
I think so.
Okay.
Maybe we should start saying that this is the machine learning working group meeting as of April 26th to be a good meeting recorder citizen.
Okay.
Um,
So
but
I'm doing that.
I'll share my screen real quick. And this was informed by a discussion I was not a part of, but some things we've been working on here at Intel. Maybe you and Connor can give like a summary of how you got to talk about this.
Sure. Is Connor on the call?
Yeah, yeah,
Okay. Connor, do you want to go?
yeah, sure. It was just a kind of a wrapping up a loose end from previous discussions. So we kind of looked back over the pain list that we at Intel had put together and previously shared, and this was one that Vish and so it's not about recommending like which one of these is the best. It's about understanding the problem and seeing how some of these tools can address machine learning requirements on Kubernetes. So it's more of just like a survey of what exists and to what extent they kind of serve some of the pain points that we saw.
Yeah. And to add to that, I think we're seeing so many different tools being developed around like application templating and package management. So we want to see whether we can extend them for this use case, or do we have to like define something new? Hopefully not, but just knowing what are the requirements and what the gaps are on existing technologies, that'll be great.
Right. And we also talking about it because we one of the organizations to build a tool like this.
Okay.
And we had some experience from people trying it out. So there's just like a few kind of machine learning oriented concerns with these tools. So it is not, like Connor said, it's not a recommendation of one or the other. So it would just be like an enumeration of some of the tools that exist, and then we can talk about like a few of the problems that might have to be addressed um, in either of those tools if we want to use it for machine learning development. So yeah, this first gap is really just like you said. Several solutions appeared around the same time, and these are specific tools that get you from source to deployment. Where some tools that have been out there have been very much assuming that you have a well-formed container that you want to deploy in different ways. Now that tends not to be the first interactions that people have, that they sit into code and they want to have it deployed. So I just want to give you an example, and this was from a user survey that I conducted, where I was like sitting next to a data scientist and saw how he used the Kubernetes cluster. And I think there are about 3 or 4 different ways where he was deploying his code, where one was he was develop at home, who push it to Git. Then from the job, he would Git pull it. Then he has another one where they were basically volume mounting NFS shares into a container, and that's where the code would live. So from the developer laptop over a Windows share would be changing the code and then redeploying. So you see that there's a lot of kind of crazy ways where this is done. Oh, and by the way, SSHing into the box, getting into the container, installing Emacs, and then editing code as well. So just in this instance, yeah, there was like 3 or 4 different ways where people were editing. And to some extent, the user experience they got was pretty instantaneous, right? They would be doing work, they click save, it would go to the Samba share, they could deploy that container. So like we said before, I think at least like 4 or 5 or maybe even 6 different projects have been coming out over, like there was like a small wave recently where I think like Scaffold and MLT, the latter is something we've built, came out like within maybe like a month in between. Draft came out last year. Discovered Forge today, which is very similar to what we have as well. And on top of that, there might be, like, this is from, they all follow the same pattern, but there are like other ways to solve this problem too, like you see with meta particle. And maybe, we've even seen cases where you reduce persistent volumes with the code in them, like you do in BiceML. And even crazy ideas like putting source code in config maps is things we've seen. So we just go through them one by one, and if I'm missing anything, or if anyone is kind of representing a certain tool, then speak up if I'm not representing it well.
I have a question actually. So when you say people are changing and developing on that code, are you specifically looking at the application code, or is it mostly the Kubernetes configuration files? And if it's also the latter, is it mostly manifest or operators? What sort of patterns are you seeing?
So from at least a machine learning perspective, people don't want to know. Right? People don't want to know about Docker or Kubernetes at all. The most common object we've seen deployed, at least, have been jobs. Meanwhile, some of these projects are more centered around services. Right? So it would focus around getting a deployment out, getting a service for it, so it becomes like reachable. So our use case has been a bit different, but a lot of these tools are general enough to support both. I don't know if that makes sense, but the key point is, for the developer focuses on code, right? Want to build code, deploy it, maybe it broke, do it again, right?
Yeah, but the thing we have to keep in mind is that there's going to be a proliferation of operators and CRDs. So whatever the solution is, it has to just generically apply for Kubernetes objects. Because it's probably managing not just application definition, but also like storage definition, resource definitions.
Yeah, you have to. And we have an example where, the data sets are not small, right? So yeah, data has to be addressed. Some jobs that we've been running have been using the TF operator, so you tend to want it to be generic. But so maybe let's go through the different projects that we have bumped into, and then maybe we can talk about the use case after. Or what do you think?
Sure. I mean, as long as we cover the use cases sometime, that's okay.
Yeah, I kind of did it, maybe the wrong way around. So this was the enumeration, and then I had like some lessons learned from our point, at least, at the end.
Yeah, sounds good, Nicholas. Let's go with it.
Yeah, we move forward pretty fast. Metaparticle is not something we have used, but it's something we have talked about, where you annotate your Python code with the metadata that is enough to deploy your application. And that is pretty much the extent to which I know about this. It needs language support, but it has language support in a handful of different languages. That's one requirement. And then the second one is, for the tool to work, then you need like a local Docker daemon that can help you with building the container and shipping it off to like a shared registry. This is hosted here if people want to try it out. Yeah, I think it kind of stands out because it's one of the only ones where I've seen there's some kind of collaboration from the language point of view, right? But it does require code changes. So GitKube, and I'm probably not, there are more than one kind of Git-oriented source to the deployment solution out there. I forgot the other ones, but GitKube is one. I think there was even a demo of this in the Kubernetes community meeting today. So yeah, you deploy GitKubeD. GitKubeD has an SSH hosted Git repository. So if you add that as a remote and you push it, then based from the Kubernetes manifest and the Docker file that are in that repository, containers get built and they get deployed, so on. And cool thing is that you don't need any other CLI than Git to drive all of this. Now, so I think the next 3 projects or tools are going to look very similar. So Scaffold came from Google, right? And have like 3 steps: build, push, and deploy. Those are, even by name, the exact same steps that our tool has. So it's an amazing kind of zeitgeist to see that so many people had the same idea at the same time. When you run Scaffold Dev in your project checkout, then as you make changes to your code, then it will trigger the pipeline again. The pipeline is configurable, which is pretty cool. So there's a big YAML describing what happens in your build, push, and deploy. And for Scaffold Run, it's like a one shot of the pipeline. There's a CLI you need to install, Docker files and Kubernetes manifest and so on needs to be in the project checkout. The Forge, it's published forge.sh. That's the website. You see, you do a checkout, and then you just do Forge deploy. So based from your project manifests, the service.yaml describes how the deployments to Docker files are wired together, as far as I can gather. So this is the manifest for your project. And in the KS, those are templates for what you want to deploy to the Kubernetes cluster. So it could be any Kubernetes objects, and then the Docker files. So you can have more than one will get built as well. So one thing that is nice about this one is that it tries to do parallel builds of whatever Docker files that you have, as far as I can gather. So it seems fast. It seems neat. Again, even this directory structure is something that we also got to. So Draft was an Azure project, and I think it's the older one of the pack. Based on my source checkout, when you do Draft create, it actually detects the code environment or programming environment that you have, if it's Python or Go, and then from that actually determines what Kubernetes objects that are needed in order to bring it up. So you do Draft create, and if you have something that looks like a service, then you do Draft up. And if you want to connect to it by using like a local proxy, you can do Draft connect. So yeah, this is the only project I've seen so far that tries to automatically determine what runtime that you have. It does require Helm to be installed in the cluster, which then means that you need to have Tiller deployed in order for this to work. So MLT was our attempt of doing the same, where the interaction is you do init, and there's a list of templates that we are keeping, that we are maintaining, and they're all machine learning oriented, and there will be per framework, per use case is the intent. So like we wanted to focus a bit more on the template management and how for people to have done a checkout of a template with the best known methods once, and once, as the project lives, can pull in updates to those best known methods. Just like with Scaffold, we have a watch support, so we do --watch, and then it will rebuild whatever files are touched. And even like the base mechanics looks very similar to Forge. We have one or two templates that are actually using on the TF operator. So if you have it installed, then if you have Kubeflow installed, then you can also deploy source code from simple TensorFlow jobs as well. Any questions so far between those? I'm probably missing some, but those were the ones that stood out.
But so, is it fair to say then, like, Draft and MLT are the ones that are actually trying to detect or like trying to adapt themselves for specific development environment or like specific runtime environment that an app needs?
So as far as I gathered, Draft does it per language. So if you look at the the things it tries to detect is like, maybe 10, 15 different languages, where in our mind, it's more about, it's like going to learning Java and going to the examples repository almost. So we have like, the intent was to have things that people could get started with really quickly. So if there's something that looks similar to what you want to do, for example, a TensorFlow voice, a voice application, there would be a template that you can pull in and use. I don't know if that made any sense. Like we don't detect it automatically. You have to specify which template that you want to base from.
So then is it fair to say, Nicholas, then like MLT is the only solution out there that is open source, which does the necessary templating to bridge the gap between VM and containers?
I think the right way of looking at this is we build like a super simple and small and dumb templating engine in one way on the back end. And I think what we're going to do is probably to align with Draft or Scaffold at some point, where the thing we care about is having like the templates are being well formed and tested, right? And then we might be opinionated about how like templates are managed, but I think it could be a thing on top, because if you look at the way that, for example, Scaffold is used, it would assume that you do a checkout of a project, and same thing with Forge, I believe, right? So you do a git clone and then you run your thing. Meanwhile, we probably wanted like a layer on top where we have like a small kind of registry of templates that people know works and that they could kind of discover.
Okay, and all these templates are all like YAML specs, right? In the sense that there's no other custom frameworks or logics that are being added.
The one thing we did, just like Forge is using Jinja on the templates, we had something dumb where we're doing substitution of, I think, like just the container image and its tag. So that's the only thing in the Kubernetes kind of template that is kind of non-uniform or non-standard, but it could be Jinja as well.
Okay. So the expectation is that I'm trying to map the user workflow in my mind. So the expectation of the MLT is that the user first generates a dummy template, and then they go ahead and change it accordingly, like as in like change it to suit their specific app's needs.
Yeah.
And then the workflow is sort of similar to like Scaffold or Draft or Forge, in that they can keep updating their source code, and then things get pushed, and then they get the job results back. Is that right?
Draft and Scaffold seem very different to me in terms of what they try to achieve, right? Like Draft is a dev tool that you use while you're coding that kind of detects like what you're trying to do based on some type of parameterization and tries to construct a container for you. Scaffold's all about CI/CD.
Right.
Okay. So
I think that's hard to say.
This seems like you guys seem like you're more focused on ease of development for machine learning applications, and the CI/CD is just something you want to pick up something from the community to handle for you.
Yeah, that is exactly. So we try to be very pragmatic. If there's something out there we could have used at that point. So I can tell you the alternative, which was our previous CLI for deploying some of these things would look for Python files and zip them and move them over. And then if there was a requirements file, then you got these kind of Frankenstein Docker files that needed to be very clever about how things were brought in. So we thought, okay, using the local Docker daemon, that's the start, fine. Because if the Docker file would pick up that you made a change to the requirements, then it would get installed. The other part of this was really to not hide the power of either Docker or Kubernetes. So if you had like a super high level, you did, your Cloud Runner and then main.py or something, then dependency management and any kind of custom behavior becomes really, really hard to do. So we wanted to just start with, if the app could be downloaded and we have like a part of our CI is to make sure that our templates always work, then that's something you don't have to worry about. Like, it tends to be the people would download bits and pieces from the internet. It may or may not work. They have to tweak it. So here they can download it, but the second they want to make changes to the Docker file or Kubernetes file or objects, they can.
So in that sense, so I guess the other example that I'm able to relate to in this that sort of meets the same workflow is this startup called RiceML. They try to provide a similar spec where the user defines what are the requirements for a given ML app, and then behind the scenes they try to do container builds and the whole deployment workflow.
Totally, but they don't rebuild their container as far as I understand. They volume mount the code in. So you have to create persistent volumes for different things, for like input and output, and for the code as well. So the container kind of stays fairly the same, where a lot of these projects are built on the fact of, there's a local Docker daemon that's okay. And then but even with Scaffold, you guys have the container builder thing, which is like container builder service, right? That you could use instead if you don't want to have the Docker daemon local. I could just, this is exactly what we're talking about now, right?
You have touched on a bunch of projects, and you touched on Forge. I think all of them kind of sort of work on the principle that you make a code change, you build it, you push it. What about things like telepresence from DataWire? Have you looked into that? Even I'm not really familiar with the project, but the documentation kind of sort of says that you can debug remotely. I think the approach that they are taking is they kind of somehow doing some networking magic to hook your code with the remote Kubernetes. So remote kube that's running over there. They're doing something around that. They're not following, I think, the build it, the build it, push it approach kind of sort of thing.
That's right. Yeah, it seemed to me to be a way where you can interject your thing, you can debug it locally, you can single step it on your local laptop, and a pipe is being put both ways. So you can interject it in your application as a whole, and then you have your single thing you can debug. That's as far as I understand it. If other people know more about it, they can definitely speak up.
Telepresence, I've used telepresence. Sometimes it's more for development and debugging. It's not for deployment. I think most of the tools that are being presented is both for development and deployment. Maybe that's the difference.
Okay, that's interesting, because I would want to understand that what's a use case that fits into that boundary versus this boundary. I guess what we're trying to address here is how do we do iterative development. I have something that kind of sort of works. I want to do some more, figure out if it works, do some more, and see if it works or not.
I can give you an example of this that was very concrete. So let's see if this is the next one. Would you mind if we get to it in a second? Because I'm going to mention an example, just like with the debug workflow. So at least one thing that is also worth noting between the different tools is for people that are used to developing in Python, the expectation in terms of the turnaround time for making a code change to it being visible is very short, right? So something that took like 10 to 30 seconds is kind of stretching it. So so we're kind of pushing some of the mechanics to its limits. Like you can only push image layer so fast to GCR if that's what you want to do from a local machine. Another thing that, for example, if you wanted to use GitKube for this, it might, even the fact you have to type and come up with a Git message might be too much for people to even bother doing it. So we saw like a lot of people still use Git for source control, but would be making changes and deploying even those changes that have not been committed yet. They may or may not be bad practice, but that's what people would be doing. So I should probably just get into some of the use cases because I've been running for a very, very long time. So this was just to show like an entire flow of what one of our data scientists would do, where they have they have a template that they're sharing between one another, and it comes with a Docker file that builds a generic container, and it comes with a submit script, which basically uses the Kubernetes API for pretty simple hyperparameter searches, where you would give them like parameter ranges, and they would fold it out into a million jobs and deploy it. And from that point on, all the jobs are running, and they write their output to the shared NFS servers. And from that point on, they use TensorFlow. So what's bad with this? A lot of the hand copied templates kind of ends up growing out of date, and we found some templates that actually were broken, where like the resource limits weren't right, and people were surprised to find out that they've been launching best effort jobs all along. So their jobs would get killed, and they wouldn't know why. Other things were that some data scientists had solved some problems in their template, and others weren't aware of those. So at best, they would both of them would solve it in their own way, and at worst, one wouldn't know about the other one, and still suffer from not knowing how to, for example, track code changes. Let's see. Yeah, and it's just like it's a regular use case that people ask, like, so how do I do X? So over Slack, people have been sending pod specs for how to start interactive sessions. And some of these people have never used Docker and Kubernetes before. That's something we have to remember.
So Nick, I have a question here. So I've heard from a few ML like data scientists that there's a use case where they launch a job, and then they want to like live debug and edit code.
Yeah.
And bugs when the code is actually running, because they're not ready to go through the life cycle of making a code change locally, and then deploying it again, and like that overhead of like going through this container build image process and then deploying it, like that seems to be a big overhead. So in that sense, like even if we had a template, how is it like, is that really going to help solve that problem?
I don't think so. I think you need something else. This is actually exactly the slide.
Okay.
So this was what people would do, right? So they would start an interactive pod, and to some extent, even for the test code to run it in a test setting, you needed like 1 or 2 GPUs. Or this was a voice model, needed like 4 to 8. And so what we would do is to start it, to kind of check that things are all right, and then actually mess around in real time with the code, and use IPDP to introspect certain dimensions of the thing. Here, the task was to use transfer learning on a multitask project. And so we want to check that the dimensions that was brought in from the previous weights kind of matched with the one that was about to be trained. So yeah, like in this case, you use the interactiveness. You use a local editor, and then you use IPDP directly in that container. I don't know if that answered your question, but that tends to be the first thing you would do before you even bother to run the full thing.
Yeah, I have a follow-up question on this. From my experience, it's usually when you want to debug, it's at the very beginning when you're creating a model. So everything is kind of unstable. At this point, wouldn't it make more sense for you to deploy Jupyter notebooks on top of your cluster with GPU? So you can try your code interactively. It might be much easier to debug. And when you kind of start having confidence in your model, then you can actually deploy just using templates at scale. What do you think?
You might, right? So from our interviews, we found that Jupyter, the pain with Jupyter was that it wasn't editing. They had to copy code out again. So once they tried it, they had to copy it out into like a real .py. And so people tend to use Jupyter for aggregation, right? So it's really handy, like for introspecting the hyperparameters and to visualize that. But for development, Jupyter was not really a part of it.
So I have a similar question with the new Jupyter lab that gives you the shell. Can't you do? I mean, we've been asked the same question that we need to SSH into the box and be able to iterate things. But I guess my question is, all that you care about is I should be able to edit my file, save it, execute a command, get the result back, right? Or is there more than that you need to SSH to the box? Are you running debugging using breakpoints and all that? Are you doing the PDB kind of stuff, right? And if the question is just editing and getting a feedback, wouldn't Jupyter Lab and the shell that comes with Jupyter Lab, that would give you the same experience?
It might. The only negative feedback there was that people tended not to like to code in an editor. So they tend to like the native experience of an editor. But I think it's doable, right? So I'm with you on like using Jupyter Lab for just like full on Python code changes. But it's not something maybe it's just because we haven't deployed it yet. So we might get to it.
Okay.
Does that make sense?
Yeah. Thanks for that. I was wondering how much of this is a habit versus like people are used to that flow. That's why they kind of sort of want to stick to that flow. Versus
definitely. And there's a lot of education to this, right? Even having the patience to sit and wait. Where if a container built in 10 seconds, I would be pretty happy. But even that could be a pain.
So some of this could also happen in a local cluster, right? Like the initial iteration where you're just like trying to get a model reasonably stable, that could happen locally, where a lot of the network latencies are out the door, and like images don't have to be full. And so it's just the build latency that's most likely the bottleneck, which hopefully is not that bad. But the question, that was not the question that I had. It's just, the question that I have is that like this workflow is probably good for Python and like any other interpreter like languages, but if the code is say in C++ or C or I don't know, like it's like say if it's a Go compile code, then this workflow doesn't apply, right? Like you're no longer, this is not a concern.
And I believe to R as well, right? Like this wouldn't apply to anyone doing any R development.
Why not R? Isn't R fully interpreted?
Maybe I just haven't tried it, but from my immediate look is this kind of flow wouldn't work for R, but I could be wrong.
But yeah, like at least for deep learning development, I only know of, well, the backends could be built in C++, but otherwise like it's usually in Python, right?
Yeah.
So that's why like I would say like 90% of people are using Python.
Yes, I think there is a big difference here whether you are talking about data scientists that are doing kind of research or early prototyping, and people doing ML for production systems. Systems, they might be doing it in C++, but definitely the scientists doing research are mostly Python and R.
Yeah, the problem.
Yeah, so
go ahead. I was just going to say that the problem with this workflow is that like you can make changes onto a container, but it's not checkpointed. So in the sense that you could probably get like one iteration working, but that doesn't mean you can reproduce that.
No, you're right. But remember the setup here, right? So they volume mount and a fair share, and so it is persistent. However, it's kind of crazy when you start deploying more than one thing. If you had another container, another job pointing to the same code, and you make a change, so it was out of necessity. I think they did this, right? But I think a part of us investing in MLT was to say, can we meet in the middle and see if they can use like real containers to carry the code as well? Mm. If you're okay, then if you don't have more questions, then we can move on to the next slide.
Yeah, I guess a takeaway is that, all right, I'm trying to understand what the takeaway is. Are you suggesting that this is a workflow that we need to prioritize, or are you saying that we should probably force people to not go down this path?
So this was just an observation of what people did, first off. Second, we've at least been looking at using K-sync where when we would be doing that, we would have an even faster way of doing an interactive container. So we do have watch just like with scaffold, but we wanted to have a way where it deploys an interactive container, basically meaning, sleep infinite, and then use casing to kind of keep the sources up to date. So instead of using a shared NFS drive, you can get this flow using that primitive.
Got it.
One more thing I would say that we might want to kind of take a look at or keep in mind is, and this is from my experience too, and talking with a lot of other, folks out there, is, once they're doing this local experience, they're training, and say they kick off a bunch of, models or hyperparameter tuning or anything like that. One feature that people would really like is to have whatever model fits the best be automatically chosen, and then, do a full build of that and deploy it out to elsewhere for further or more extensive training. That's something that seems to be on the front of mind for a lot of ML engineers out there.
Okay, so was that to kind of emphasize that you want tested, about to say best practices, but you have like a stable place to start, like a stable base?
Yeah, so like if I build a model, or if I'm developing locally, right, and I create, I have some code, I check it in, and I start to kick off some training, but I often need to tune different aspects of my model as I'm going through this workflow. What I'd like to do, or what I'd like for the end result to be a final model, or thing that seems to be the thing that works the best or whatever, and then that be the thing chosen to go through a full development build or whatever, and that kind of be chosen automatically to the best of it, to the best of the ability.
I think it gets into kind of experiment tracking land at that
Very
point.
much.
Yeah,
And,
I agree with Niklas. It's really, I think, next step. What you say really looks similar to Google Vizier, and Kubeflow has Katib that try to do that. But then you need model management, model storage. Also, different people will need different metrics to evaluate models. So it becomes very more complicated. But this is definitely interesting, but very complicated.
Yeah. So I think maybe Connor can talk to experiment tracking next time. So we've been doing some work there as well.
One more question around this.
Yeah.
So is this workflow equivalent of saying, rather than doing a shared NFS, I could have done, as soon as I save my code, I trigger off kubectl copy followed by kubectl exec, whatever command you want to do. Right?
Can you say that one more time, please?
So is this workflow that you have on the slide up, say if I have a container running and I have the pod ID, is this flow similar to me doing save a file? As soon as I save a file, trigger off a kubectl copy to the pod, I have the pod ID, followed by kubectl exec, I know the command that I want to execute, right? So is that the equivalent of, and you don't have shared NFS, you don't need to get into the container. You're basically saying, as soon as I save something, just do a kubectl copy, kubectl exec.
Yeah, you're totally right. And there is some kind of intelligent server client ways of doing this, right? So Ksync is one. And that is one project that came out also like a few months ago. You can copy individual files. You could use, some people talked about having SSH there, so you can use rsync. So there's a bunch of different ways. At least like from a principle standpoint, I like the idea of the container being kind of self-contained. So, the code will go there, right? But that again, so we're making different bets and different assumptions about what the user is willing to kind of accept in terms of turnaround times and kind of the mental model of what they were used to do and what they're now supposed to do in this containerized world.
That's fair. Thanks.
Yeah, so another thing is when we have one of our data scientists tried out MLT, and it was for a model called UNet, and it's used for kind of biomedical image I would say recognition. but it's used to detect cancer in this instance. And we had to use a tool like KVC. So that is the tool that Biology has been working on, in order to bring in, I think it's like tens of gigabytes for a small example set. So that was, this is just like indicating that, at some point, I think we need to make all these tools work together, right? So once you make a change, the thing you should deploy, it should probably have some notion of being tied into the experiment tracking or the hyperparameter searches. It needs to have a tie-in to how to bring the data to the node and so on. So this is just like a call out that we saw one instance where we tried to use MLT. It had to be used with KVC, and integration was like a bit awkward, but something that we would hope that I don't know if you choose like one way of doing this, like for the ML use case, but that's something that these tools will have to factor in at some point.
So Nicholas, just to make sure I understood, KVC is handling identity for storage objects, right? It's not trying to solve the like getting stateful partitions for multiple workers.
At least the way that they used it was to download this brain set, and that for this scaled down version is 12 gigs, and for scaled up is about 1 terabyte.
Okay.
But they did use it in a way where they provisioned enough of those like PVs where this has been downloaded to, and then bound it to the jobs basically as they were running.
Okay, so there's still the other issue of like giving a stateful partition to keep checkpoints around.
That's right. So like for the output, that's different, right? So this was just KVC was just for the input.
Okay. At
this point, and the output that they did for this demo actually just pushed it to something like S3.
Okay.
Where we would like to have a kind of generalized way of doing this, but that has been the easiest way because then people can use TensorBoard directly. But for people that cannot use S3, you can only go to NFS, and the way that people have been encoding the outputs have been like fairly like mind-boggling, where you would encode like all hyperparameters in the directory name, even the F1 scores directly would be encoded in the directory name. So people don't get stuck. They try to kind of solve it in the best way that they can. But I think there are some opportunities to do it in a more structured way. I think the reason I made this slide was just to say you cannot avoid dealing with data, especially not the input. So yeah, like I don't know if there's much more to add to this other than there needs to be a way for us to tie in with tools that deals with data. Like this kind of like the iterative code development probably doesn't need it like immediately, but it needs to be a way for like to tie into it.
Yeah, I agree.
Can I add something to that demo? So the input also was from S3. The reason why, we don't still handle like sync support in KVC, S3 sync support in KVC is because we have to handle writes from multiple workers. So in the demos case, they used tf.data as S3 support. So the master will take care of making sure that the data is uploaded into the S3 after by the end of the job.
Okay, got it. Yeah, the other thing to note there is that like we don't deal with object storage at all in the Kubernetes space, so that makes it harder to provide abstractions there.
Yeah.
I had a question on the KVC as well. So if I understand this correctly, all the KVC is doing in an NFS world, and I'm not sure how do things work in S3 world. All the KVC is doing is basically bringing the data close to compute, right? All you're basically saying is, I have a bunch of compute nodes. I have KVC. All KVC is going to do is it's going to bring in that data and put it on the compute nodes, right? That's how it differs from any regular PVCs. I could have basically brought the same data over to PVCs as NFS. And what KVC is doing is it's saying that I have a bunch of these nodes which have my GPUs. I'm gonna mark them that these nodes are basically dedicated for doing, say the brain data set. So KVC, go ahead and copy this data and bring it over to these nodes. Is it doing sharding as well? I don't think it's doing sharding as well. Basically, it's going to take the entire data set and it's going to dump into each of the boxes.
Yeah, so it doesn't do it for NFS. It does it for object store, like S3 compatible storages. And replicates it across all the nodes. It also can be a data glue between some of the file systems that are not natively supported. We have support for Pachyderm file system right now in KVC, and we have some ongoing work to do other file systems as well that are not natively supported in Kubernetes. But in case of NFS, it directly uses the persistent volume and persistent volume train. But that's not the popular way that people use KVC. It also doesn't place any restrictions on which node it has to be or anything like that. It just gives you a node affinity field, so that you can land your pods there.
Perfect. And question on, if you're doing it that way, then why would I do KVC versus not doing standard S3, at least for the frameworks that support it? Like if TensorFlow supports native S3, that's one. And the second one, why wouldn't I just do mounted S3 then?
So what do you mean by mounted S3?
So there are plugins out there which let you do mounted S3FS, right? You can just basically take a bucket and mount it as an S3FS bucket on your local file system, just like NFS, just like the way you would mount NFS.
The semantics are actually different for S3 and GCS. So a lot of times when you try to mount object storage and use it as a file system, the behavior that you get is unexpected.
Yes.
There's also the issues of like authentication and making sure that you handle the right IAM rules that are being set up in each object. So like mapping, it's not just about access to storage, but also the whole life cycle of that.
And the performance is usually poor. So object storage backed file systems generally are not super fast.
Yeah.
But for any writes or mutations you make, it's pretty awful.
So the difference between tf.data S3 and KVC is that KVC locally caches it. tf.data only loads the data set after the data is already there. Like for example, even if you use tf.data's S3 support, it'll download the data during the runtime.
Okay, that's fair.
Are there any plans to add support for GCS as well, or it's not on the roadmap?
There's actually going to be a KVC.
It is already supported.
Okay.
But
it's already supported because S3 GCS is S3 compatible, so you can use S3 type in KVC and it'll just work.
Have you tested that?
Yes.
Did you verify?
So we actually.
How did you get the security credentials to work?
Say that again.
So do you handle IAM?
Yeah, GCS and S3 are compatible from an API perspective, but the authentication credentials that they use are fundamentally different. So like typically the S3 SDK from Amazon AWS, for instance, doesn't actually work with a GCS bucket.
I know, we use a Minio client.
Okay.
Oh, Minio, okay.
And it just does it for you. Okay.
So yeah, it works. I mean, I've tested it in like Minio cluster, AWS S3 and GCS.
Okay. Cool. And I have a different question. Like caching is not necessary in all scenarios, right? In the sense that if the data is already set up, say in a dataset format, like in the case of TensorFlow, there's no necessity to like download it locally before starting training, right? Perhaps I guess like I'm wandering into like KVC territory, which I should probably hold on until we actually talk about it.
Yeah, okay, we can have this conversation later when I present KVC. And I can answer all those questions. I don't want to hijack this presentation.
Okay. It's fine. So I'm done. I hope that it helped a bit. Just understanding that there's a ton of these tools from source to deployment out there. Internally, we are looking at how we can compose rather than trying to replicate but just from a practical perspective, this development on these projects I think started around the same time, like start this year, and so without knowing, we were redoing each other's work. So with that, I don't know, do you have any other kind of comments or questions? Just trying to give like an overview. I might have missed some tools, so if anyone knows that any other tools we can add or talk about them.
The SIGApps are trying to come up with a more complete list of all of them, and there's just so many in the ecosystem right now. You mentioned a few of the kind of larger ones. Yeah, there are some commercially supported ones which actually didn't come up. If you talk about Draft and Scaffold, was it Weaveworks?
Yeah, Weaveworks has one.
Yeah, Weaveworks has a CI/CD system that's Kubernetes based. Basically GetOps or GetFlow type. There's another one, CodeFresh.
Yeah.
So I mean, like, there's just tons and tons of them. I don't know if it behooves you to review all of them.
Yeah, I feel like they're all mostly lacking the ML specific templating stuff, right? Like that's the key piece that's missing in all of them. And so if you can literally like give people just that part, which is a user being able to describe what sort of ML app they are developing and what are some of their dependencies, and then like if that's like one of the first steps, or like maybe there are adapters to then adapt to one of those CI/CD workflows. That way you can just like get out of the way and then just solve that specific problem.
I think the hard part is that for CI/CD for stateless serving workloads, where it's like, let's say a website or like a store of some type, right? CI/CD is kind of a well-known space there, right? I think for machine learning, even the workflow is kind of up in the air at the moment. Like, we're still trying to figure out what that looks like. And then the other problem is it's different types of teams, like data scientists, data engineers, machine learning specialists or researchers are all different people. So understanding each of those personas, how they interact with different organizations, is probably still kind of an open question as well. So there's some best practices around CI/CD for stateless serving workloads. There aren't any really best practices for machine learning workloads.
Yeah, I agree. So you don't have to be precise about what it should be, but giving people a vehicle for moving from their existing, say, desktop or a virtual machine environment to then adopt all the rest of the awesome stuff that is happening in the Kubernetes community, there's value in that, right? Like just that small glue, even if it's not feature rich, as long as it shows the rest of the ecosystem that exists, that's still a big win.
Yeah, there's a lot of value in leveraging existing tooling from the ecosystem in order to support this specific use case.
Yeah, but trying to support all of them is also going to be difficult. So it's probably.
But that's why I think composability is going to be so important. Like if you have like a targeted experiment tracker thing, right, or hyperparameter thing for Kubernetes. What else? Like I'm kind of already running out, which is not very good. But you have different ways of stringing together, like solving like the data issue or visualization or whatever it might be. But you have like the targeted applications. I hope, because a lot of the things that's been out there are like the quote unquote studio, right? Where everything comes as one big bulk, and you can really like, how do you use half from this and half from this, or one from this? So I kind of hope that we, like as an ecosystem, would go that way. If there are like some good practices for the handoff, right? It's like CRDs are pretty easy to create, right? As one thing.
So how does Scaffold work? Are you familiar with that, in the sense that can we plug in templating in Scaffold? I know we can plug in.
I mean, you could provide, so some of the things that I don't think you could do, like the idea that you're going to be able to modify the code and then do like pause the container while it's running inside of a cluster remotely. Scaffolding, I don't think is going to support you there, but it does support CI/CD. So like if you have a flow where, let's say you're doing debugging locally and eventually you're done with the model enough that you want to like build it into a container and deploy it into a staging or a production environment, Scaffold can help you with that part of the flow.
I think
but it really is CI/CD focused.
okay.
Which is like, and it seems like to me, from what was presented here, CI/CD is like part of this story, but the real story is it's practitioner and experimentation focused. Like it's for rapid iteration on a model, being able to like develop something quickly, get it out the door, train it, not necessarily freeze it and ship it.
Well, actually, I don't know, like Scaffold, one of the journeys that I saw with Scaffold was that you're doing initial development and then like you're making code changes and that it gets deployed right away. And that's sort of similar to the ML scenario here.
Well, I think so. But I mean, Scaffold, typically the dev environment is going against Minikube. So you're doing your local changes and it's deploying locally, right? So they're not doing full production deployment.
And that's still
That's fine, yeah.
right? But what about templating? Like when it comes to template generation, like job specs and
They could do
PVCs
that. Yeah.
Okay.
But they don't
it's
have
not
an opinionated.
catered to that. Yeah.
Yeah, it's not
You can
opinionated.
do it, but it's not catered.
Okay. So if we can plug in that piece,
Yeah.
then that could be a way forward.
Like you
With
could,
Scaffold.
yeah, you could use it for a CI/CD system, or I don't know. It's not generic enough that I would call it like a workflow orchestrator,
Okay.
right? So it's not Airflow, it's not Argo or anything like that.
Right.
It is opinionated to the sense that it's really meant to build code and build containers and ship them into production.
Right. But you still need a templating tool that generates the Argo or Airflow config, right?
If you wanted to, I mean, templating is sort of an optional, like, especially if you talk to Brian, right? Templating is optional,
Okay.
right? you can use, what's Conflate called nowadays? Customize, yeah, right? So Customize works on raw manifest and has no templating whatsoever. And that's a valid interface to the system. I don't know if that's the right interface if you're using TensorFlow.
That still is just defining how the user interacts with your templating engine, right? So in a sense that
there's no templating if you use, so like, let's say you use Scaffold and Customize, no templates.
Okay, so it's
Right.
all happening in the server side.
No, it's client side. It's just it's almost like sed and awk, right? Like you're proposing edits to a set of manifests that get applied for you and then reified into, basically raw manifests. But there's no like, I have a template and I fill in and parameterize values and that's what ends up materializing my infrastructure. So
Got it. So in the sense that you have some golden manifest and then you're just like making edits to it and patches to it.
Right.
Okay. Yeah, that makes sense too.
Okay, I think we are over the hour already and didn't get to the other items. I hope this was helpful, but yeah, like I'm gonna pass it on.
Yeah, it looks like the other items are pushed out of the agenda, so I guess we'll probably discuss them again. There's one thing that I wanted to find out, if are any of the folks going to show up at KubeCon, so we can probably have an informal session there. And I can send an email about this and we can probably sync up our email too.
Yeah, I'll definitely be there.
Okay. Yeah, if you can, maybe an email thread, if people can say who's going to show up, then we can coordinate that. Okay, I'm gonna stop recording now.